All right, getting into section 15, which is z-scores. It's really fundamental that you know what a z-score is. So basic. A z-score is the number of standard deviations your value is from the mean, period. So if I say we have a z-score of 1.2, so this is the z-score. That means you are 1.2 standard deviations above the mean. How do I know it's above? Because this is positive. So a positive z-score means you are above the mean, while a negative z-score means you are below the mean. So here down in this bottom example, this means we are 3.1 standard deviations below the mean. And we know it's below because we are negative. So that is the basic concept of what a z-score is. Now let's get to actually calculating it. All right, we are here on page 137. Now, this is important. And I'm more about the words than the symbols because the words are what you're going to remember, right? X minus mu over sigma doesn't mean anything to normal people. Only math geeks like me remember crap like that. So focus on the words. The z-score is the value minus the mean over the standard deviation. So the value, whatever value we're talking about, minus the mean over the standard deviation. So we're looking at this example that they give us. The mean is 70 inches, the standard deviation is 5. We want to know about the man who's 63. So 63 would be considered the value. So value minus the mean over the standard deviation, we would end up with negative 7 over 5, which comes out to be negative 1.4. So we are going to work through the next 5 examples. All right, z-score of 65 inches in height. Well, the z-score is 65 minus the mean of 70 over 5. So when I work that out, I get negative 5 over 5. The z-score is negative 1. That means this man is 1 standard deviation below the mean. That's what it means. All right, actually, I want you to hit pause, and I want you to try to do 2 through 5. Come back, and I'm going to look at all 4 of them, but I want you to try them first. So hit pause and try them. In number 2, we have a 77 inches. So the z-score is the value minus the mean of 70 over the standard deviation. And I really want to focus on order of operations, so we've got to do the top first. I get 7 over 5. So the z-score for this guy is 1.4. So he is 1.4 standard deviations above the mean, right? It's above because he's positive. In number 3, we've got 6 foot 2 inches. Well, what do you have to do first? Well, Becky, we have to turn it all to inches. Yes, you are correct. So remember, if we go from 6 feet, 1 foot is 12 inches. So the 6 feet is the same as 72 inches. Plus the 2 inches I already have, this guy is 74 inches tall. So data minus the mean over the standard deviation, we end up with a z-score of 4 over 5, which is 0.8. So this person is 0.8 standard deviations above the mean. Notice how these numbers are not quite as crisp as they were with the empirical rule. That is the whole point, right? The empirical rule was an estimation. These are a little more exact. Number 4, how tall is an adult male who is 3 standard deviations above the mean? Well, the mean is 70. He's above it, so we're going to add to that, and we are going to add 3 standard deviations. Well, the standard deviation is 5. So if I add 3 of those, I need to add 15 to his already enormous height of 70 inches. And I say enormous because I'm short. And therefore, this person is 85 inches tall. Now, number 5, Yao Ming. If you remember Yao, he played for the Rockets. He is, I guess he's still alive. 7 feet 6 inches tall. Same concept of we've got to change these feet to inches. So 7 feet is 84 inches, plus the 6 extra inches. Yao Ming is 90 inches tall. So if I take his value minus the mean divided by my standard deviation, Yao Ming is 4 standard deviations above the mean, right? That is highly unusual, as we will talk about data. So, okay. Page 138 will become your new best friend in this section, and this is what we call the z-score, the probability table. So when we had the empirical rule, we could just look at the data and find where the number is and then add the percents going to the left or the right. Well, with the z-scores, we're not as, we're not as closed in. We have more range, more possibilities. And really, even this table is pretty limiting on our numbers. If you would take a statistics class, you would have a much larger z-score table. So here's the deal. This table always goes to the left. So if I would say I have a z-score of 1, here's my z-score of 1, the probability to the left is 0.8413. That's what it means. We can also use it going the other direction. I will take pictures of this table and throw it in periodically as we work through these problems. So I do want to look at the top problem on page 138. So on the top of page 138, there's these two questions, and we want to know about being shorter or taller than 63 inches. Well, 63 inches is not a z-score. So you will notice that the first step was to use that formula we used on that last page to find the z-score. So we now have a z-score of negative 1.4. So when you think about it, if we would draw a graph here, we know that the mean is in the middle. So this is the mean. And a mean has a z-score of 0. Yeah, we'll get to that in a minute. But a negative, right, is less than the mean, so it's over here. So if I went shorter than that, I want to go this way, and greater than that would go to the right. Well, when we look at this table, and we're looking at a z-score of negative 1.4, negative 1.4 is right here. So this value tells me the percentage of the proportion of people to the left, or shorter. So what proportion, oh man, I cannot read. What proportion of men is shorter than that? Well, based on our table, the answer would be 0.0808. Okay, because that goes to the left. Well, we know how many are taller. Well, if 0.0808 are shorter, then all the rest of them are taller than that. So we would take 1 minus 0.0808 and get 0.9192. Because together, the shorter and the taller, that has to be everybody. All right, here in example 6, we're talking about Danny Devito. So Danny Devito is 5 feet tall. What is the z-score for Danny Devito? Now, we know the mean is 70 and the standard deviation is 5, right? Same data. But we're talking about inches. So we first had to figure out how many inches tall is Danny DeVito. Well, if he's 5 feet, multiply that by 12, he is 60 inches tall. Okay, so now 60 minus 70 over 5, negative 10 over 5, we've got a z-score of negative 2. Now, I know I've said this before, and I will say it again. I'm a visual person. So here is Danny DeVito on the graph at a z-score of negative 2. Part B now, what proportion of the population of men is shorter? Well, if we want shorter, we want to go to the left, right? Shorter to the left, that's less. So when you look at that graph on page 138, find the z-score of negative 2. It tells you 0.0228. That is the proportion of men shorter than Danny DeVito. Now, that is very hard to comprehend. Like, what does that mean? 0.0228 is, what? Well, that's like out of every one. So I'm going to go to part C where it says out of 100,000. So I have 0.0228, and that is, it's a number, so I can make it a fraction by putting it over 1. And now we want to say, okay, that's like out of every one person. What if I wanted it out of 100,000 people? Right? Because this will allow us to give us some data that makes a little more sense. So when I cross multiply, 1x will give me 2,280. So out of every 100,000 men, 2,280 of them will be shorter than Danny DeVito. Now we actually have some numbers that would make sense. Now we can quantify things. Instead of saying 0.0228, well, what the heck does that mean? Now I can actually talk in terms of numbers. Out of 100,000, 2,280 of them will be shorter than Danny. All right, going back now to letter D. Well, if we know the probability of them being shorter is, shorter is 0.0228, taller is everybody else. So 1 minus 0.0228 would give me 0.977, whoa, I forgot the 72. All right? All right, I would like you to try 7 and 8 right now, here on this video. Okay, looking at number 7, the average height of women in the U.S. is 64 inches. So, what is the z-score for the average height of women when compared to men? So, we are now going to use this as our data value. And we're going to keep the 70 for a mean and 5 for standard deviation when we did before. So, 7a, we've got our 64 inches for the women minus the mean for men over the standard deviation, and we get negative 6 over 5, which is negative 1.2, right? There's our z-score. So that's part A. And if I look at this graph, right, here's 1.2, about negative 1.2 right here. So now, part B, what is the probability a man is shorter than the average woman? Okay, so the red line is the average woman. Shorter than that would be to the left. So I would look at page 138 in the data and find negative 1.2, and I would get 0.1151. So 11.5% of men are shorter than the average woman, right? That's what that means. So if this over here is 0.1151, then everything else would be taller. What proportion of men are taller than the average woman? Well, 1 minus 0.1151 should give me 0.8849. Okay? All right, looking at number 8, the tallest jockey to win the Kentucky Derby was Johnny Sellers at 5 feet 7.25 inches in 1961. Mr. Sellers was taller than what proportion of men? Well, first let's find his z-score. So, if he is 5 feet 7.25 inches, okay, well 5 times 12 gives me 60 inches, plus this inches over here. Johnny was 67.25 inches. So 67.25 minus the mean over the standard deviation, I get a z-score of negative 0.55. All right, so that's his z-score. Now I want to go back to the picture. So a negative 0.55 is somewhere around here. So here's Johnny. There's Johnny Sellers in the orange line. He was taller than what proportion of men? So we're trying to talk about all the people that were shorter than him. All right, so everybody that was shorter than Johnny is over here. So that's what we're trying to find. Well, if I go to my table, right, I'm looking at a z-score of negative 0.55. I see 0.2912. So write a sentence interpreting your answer. And so now we could have like 5 gajillion different answers. That's just an easy sentence that I typed in. Johnny is the orange line, and there are 0.2912 less than him. So that means he was taller than 29.12% of men. Right? You could talk about he was shorter than 70.88% of men, or anything that kind of comes across in that respect. So I'm going to call that video number 1 for z-scores.